Okay, good morning to our in-person audience in the iHotel. Good afternoon and good evening for those of you who are joining us from other parts of the world. Welcome to the University of Illinois at Urbana-Champaign. Welcome to this workshop on smart contract and decentralized insurance. So we're all here today, I think, because this incredibly interesting topic. Almost everybody who I know of who have done anything with crypto, they always link this, compare this development DeFi in the early 2020 to the gold rush of the 1840s. So we're certainly at the right moment, a historic opportunity to enter into this uncharted territory. There's certainly lots of opportunities for business development, entrepreneurship, research, education. So this is really a perfect time to learn. And then while this is very exciting, it also creates anxiety for people because if you don't keep up, you will be left behind. So we're here today to address some of that anxiety. We have an exciting lineup of speakers and topics in this workshop. I'm very happy to see that you're all here today to spend a significant amount of time to learn the subject. And whether you're a beginner or an expert, I'm sure you will have something to pick up today. So let me introduce the first speaker today, Riley Kilgore, who is an engineer, graduated from the University of Washington. And he has a degree in computer science and mathematics. And he has always been quite interested in crypto. He ran a Bitcoin node in his teenager years. And since graduation, he started to help out, start this first decentralized autonomous organization on the Cardano Blockchain, which is called ADAO. And he continues to work on building these protocols and tools for the community. So let me please welcome Kilgore.
Thanks for being here. And as I was introduced, my name is Riley Kilgore. Today I'm presenting two lectures. The first is an introduction to blockchain and smart contracts. The second will be an overview of decentralized finance, and I'll have some time for questions in between the two lectures as well as at the end. Perfect. A little bit about myself. I just graduated from the University of Washington a couple of years ago, and prior to that, I didn't actually get into programming until near the end of high school, but I've always been really interested in computers. I've been really working hard to improve my skills ever since I got interested in programming, and I've really taken a passion to it. In sort of the recent months and since near the end of last year I helped start ADAO. We build a lot of open source tools. We have nearing 40 open source repositories in GitHub. We are just trying to improve the Cardano ecosystem and make it as accommodating as possible for DAOs and other organizations to kind of convene within the Cardano blockchain. But I'm going to move on from myself and what I've been working on. I kind of want to just get into the talk. Bitcoin is the first blockchain that emerged back in 2008, and the premise was pretty simple. We want to reward people for securing the network, and so we're going to reward those people in a fair and equitable manner based on how much work they're contributing to the network, right? And you have these miners, and a lot of people in the past actually just plugged in USB drives that were made to be miners into sort of power slots on their computer, and that would allow for them to mine Bitcoin, and you could run it on just any desktop for a long period of time, and now it's much harder, but the idea is still the same. If you contribute the same amount of computational effort as somebody else, you're going to be earning the same amount of Bitcoin as somebody else. In recent years, we've had a lot of innovation within blockchain. There's a lot of things that have been done to allow for scalability, but also there's been work done in allowing for programmability and smart contracts so that people can actually create usable systems as opposed to just representing value on these secure distributed ledgers. But what really is a blockchain? As I just said, it's a distributed ledger that's secured by a bunch of people contributing some sort of work to validate that ledger, right? But the idea is that you have some sort of information and it's represented as a transaction, and if you just send some value to yourself, you can attach a message to that if you wanted to, for example. Once you add that information to the chain in the form of a transaction, which is included in a block, that block is on chain forever. It doesn't have the ability to be changed, and so that immutability of the ledger is what actually allows for us to have usable systems that we can rely on built on top of these systems. When it comes to consensus and actually securing the blockchain ledger, there's a variety of different methods that have sort of popped up in the past decade or so. Proof of work is obviously the most well-known, and the idea is that you're contributing to the network with your computational efforts. You're actually trying to solve this problem, and the first computer out of all of these groups to solve that problem is the one that's awarded with the ability to mint the next block. Basically, everybody wants to add to the blockchain in the form of adding these blocks. They get paid to be the block producer, right? And so if you're contributing more, then you have a higher likelihood of getting that reward. In proof of stake, we actually don't use computational effort to define the system and how consensus is achieved, but instead we use how much stake is within a given system or pool. And so in like the model that Ethereum is trying to move to, you basically would have stake all held within a certain address, and that address is basically run by a node, and that node is helping secure the network, and it's based on how much stake that node has in it. There are some networks that actually allow for your assets to be stored in separate wallets, but still be delegated to the same block producer. And I think it makes sense when that's able to be achieved, but it's not always possible. So still talking about consensus, I've got an infographic here on staking, and like I said, the idea is that users are actually able to put their money to work for them by having it be used in the consensus mechanism to get them a higher likelihood of printing a block, and in that process, they're, like I said before, rewarded. So the main benefit of proof of stake as opposed to proof of work, and the one that's touted by most people, is the sort of ecological benefits. Proof of stake takes significantly much less energy than proof of work. It's like 0.02% or less than that for most proof of stake systems compared to proof of work. And so a lot of people are petitioning for proof of work systems to be banned, but then on the flip side, you have people that are in the proof of work camp who are pushing for all of these tokens that can be used for proof of stake to be considered securities. So there's back and forth from lobbying in either direction. When it comes to the programmability of blockchains, though, and if anybody has any questions, feel free to stop me at any time, definitely. When it comes to programmability, which is really important for usable systems, as I said before, Ethereum actually was the first blockchain to achieve sort of an expressive programmability layer, and what that means is that you can write smart contracts that actually control the flow, the use of funds, but also the creation or destruction of assets that are represented by other smart contracts within the system. So there's been standards that have been set within the Ethereum ecosystem and other Ethereum virtual machine or EVM chains, and basically those standards are followed by wallets and by people that are minting these assets or writing these contracts to mint assets, and that's how it works in some chains. They also have other chains nowadays like Cardano and Ergo, where these assets are actually represented natively on the ledger, as opposed to being represented as a smart contract. But there are sort of trade-offs to either approach. Talking about what a smart contract actually is, it's code that's on a blockchain, and it's allowing for multiple people to interact with the system without having to necessarily trust one another is generally the purpose of these contracts, but they are relatively arbitrary in what they can represent. In the future, a lot of people are hoping that even things like real estate are represented by blockchain transactions. I think that the primary hurdles there are around lobbying and politics. I don't think it's around the technical aspects, but that's a whole nother conversation. At the level of the blockchain, though, smart contracts are just represented by a small number of instructions or primitives, and that's similar to how regular computing works, right? People talk about zeros and ones, binary instructions for computers, and so the basic idea is the same. It's just that these sets of instructions have been defined in a way that it's convenient to create financial systems on top of these blockchains, and a lot of blockchains do it slightly differently than others, but there is, as I said before, a lot of these EVM or Ethereum virtual machine chains that all run the same type of contracts. They all have the same instruction set. When it comes to digital assets, and I've talked about this a little bit in the previous slides, they can be created or destroyed with conditions that are specified by these contracts. And it's actually really useful to be able to define the conditions upon which assets can be minted or burned in a digital format, because it allows for us to create basically arbitrary systems of complexity where a claim in a system is represented by digital assets. In the context of like exchanges, this is a model that's used a lot to represent how much liquidity somebody has contributed, but I'll be talking about that more later in the talk. Like I said before, smart contracts live on a blockchain, and they sort of define these rules as to whether or not things can be spent. There's actually multiple different models for how smart contracts can be written, and the two competing models, or the primary competing models, are the account-based model, where basically there's this ledger and it keeps track of everybody's account, and so at any point in time the system knows how much everybody has and what data is represented. It's relatively easy to create systems in that type of model. There's also a more novel model that is being used by a couple of blockchains and some layer 2s, which are scalability methodologies. But the UTXO model is what Bitcoin used, and it stands for unspent transaction output. And so the basic idea is that there's transactions. A transaction can have one or many outputs, and each of those outputs prior to being spent is considered an unspent transaction output. After it's spent, it is no longer unspent, and therefore it can't be spent again. The way that you write smart contracts in these models do vary quite widely, and there's much more established design patterns in the account-based model than in the UTXO-based model. So like I said, you've got this sort of ledger in the account-based model, and it keeps track of everybody. And so transactions occur in a sequential fashion. We say that one person is sending money to another person, or maybe it's a contract that's sending value to another person, but that transaction updates the global ledger, and as you notice, there's a small amount missing in the second box to the right, and that's because every time that a transaction occurs on a blockchain, there's a small fee that goes to pay for those people that are validating the network. And so when people are, like I said, validating the network, they're getting rewarded for it, and this is where a lot of that reward comes from. The benefits of an account-based model really come from, again, the fact that it's really easy to sort of think about. You don't have a whole lot to consider when it comes to like where to store data, because it's all accessible, right? The contracts that you write in an account-based model can easily see the state of the ledger, and it's easy for them to access a variety of variables. Additionally, in an account-based model, you actually write all of the code to be running on-chain, so anything that is matching orders within an order book, or searching out things on the ledger, that does occur on-chain within an account-based model. In the UTXO model, we have basically all of the data represented locally within those UTXOs. So like I said, you have a transaction which can have one or many outputs, and in order to write smart contracts using this model, you basically just have to attach data, and that data can have sort of an arbitrary format, but you attach data to these UTXOs, and then that way the smart contracts that you write validate whether or not spending can occur from a certain address. And so any UTXOs in that address have a certain piece of data attached to them, and that sort of validates whether or not, and it's included in the validation code as to whether or not that UTXO can be spent by any given transaction. So the smart contracts in the context of the UTXO model only have the ability to see their inputs, their outputs. It's not able to see sort of the global state of the ledger. And this has some benefits and some deficits. The primary downside of this is that it's much harder to create complex systems within a UTXO-based model. And additionally, with the novelty of sort of extending it with data that's only been done in the past handful of years, there's not nearly as many design patterns established within this type of ecosystem as there are within something like the account-based model. But some of the benefits are that you have a lot higher concurrency with this type of model, because transactions don't have sort of this concept of occurring sequentially. If there's two separate UTXOs and I want to use one UTXO for one transaction and another for another transaction, those transactions can occur at the same time. There's no sort of concept of which transaction comes first in a block. So I wanted to kind of walk through a couple of examples of smart contracts in both of these models. And this is going to be probably the most dry part of this presentation. Like I said, if anybody has any questions at any time, feel free to stop me. In an account-based model, if you wanted to create a multi-sig, and I should probably explain what a multi-sig is first. It's a multi-signature wallet is basically this concept of having an address or a wallet where you have to have multiple signers that are agreeing to spend anything from that wallet. So you could have an arbitrary N of M wallet, say 5 of 7, where 5 individuals need to agree to spend assets from that wallet in order for assets to be spent. And it's really helpful for groups that are looking to coordinate on blockchains to have systems like this. Businesses can leverage this type of thing if they're interested in blockchains, but especially for groups that form around a blockchain, having these systems for coordination are essential. In an account-based model, the way that you would have to write this is basically that there's a set of endpoints within the contract, and you're writing, again, all of this to run on-chain, but these endpoints need to be considerate of adding new people to your multisig, removing people or replacing them, modifying the number of people that are going to be on the multisig, and all of those things should be represented by a transaction that needs to be voted on by the current signers, and in order to do that, you need to be able to create transactions, you need to be able to sign transactions. I think it's likely something that people want to be able to revoke signatures on transactions. And then once a transaction is ready to be executed, you need some sort of way to execute those effects. And so what it comes down to is, again, this sort of idea that you have all of this code that's running on chain to do everything in the account-based model. In a UTXO-based model, the on-chain code actually can be quite a bit simpler, but there's this concept of having off-chain computation code that actually has to be forming those transactions that we talked about, spending those UTXOs. And so one of the benefits is you're able to kind of take that load off of the chain, but one of the downsides is it does create a little bit more complexity in the systems you're building. The on-chain code just needs to be basically stating that a certain number of signatures are required on a given transaction, and that those signatures need to come from a predetermined list. Both that list and the number of signatures could be stored on a datum, so you could have one address that has a variety of different people's UTXOs. But there's also, in some UTXO-based systems or blockchains, there are actually sort of limited smart contracts that can be used as well as more expressive ones. And in Cardano specifically, which is the blockchain that I work within, there's something called native scripts, and these native scripts are not nearly as expressive as traditional smart contracts, and we do have traditional smart contracts as well, but these allow for us to just basically configure multisigs really easily and in a way that everyone can kind of audit. There's no sort of audit surfaceability here, which is really convenient when it came to trying to get something out, but we do have a version of that live and open source if anybody is sort of interested in digging into what that off-chain computation code looks like and such. But like I said, the off-chain computation code is actually what's looking at the UTXOs, and in the context of having different datums, it would look at the datums on those UTXOs and decide which ones are relevant to a given user, and it would allow for the user to specify transactions that are going to spend that UTXO or UTXOs, and maybe some of that value goes back into the multisig, maybe some of it gets spent to another multisig, and it's sort of all of that work is delegated to the off-chain code, whereas the on-chain code, like I said, is just checking simply whether or not the signatures are there. Similarly, with an order book in an account-based model, and I hope everybody's familiar with the concept of an order book, just sort of being able to post up an order for one currency and another currency, for example, or an asset for a currency in the context of like some order books. But in an account-based model, all of the work needs to be done on-chain. It's really expensive to do this because you actually have to match orders. And so you have to kind of search through on-chain for which order would match a given order when adding a new order to the order book. But basically, there's just these endpoints that are needing to be defined for placing orders and also canceling orders for both selling and purchasing. But the way that those are defined are basically the same, because it's just the concept of two currencies, right? But in this model, it is kind of nice because anybody who's posting an order, I mean, it searches through the order book, and if there's already an order within the order book that sort of matches with the user's new order, that'll automatically be filled. In the context of a UTXO-based model, you just define on-chain that there's going to be basically UTXOs that have a certain price assigned within that datum and a user defined within it. And the UTXO needs to be spent in a transaction where enough value specified from that UTXO is sent to the owner that is specified in the datum. Either that or the value can be transferred back into that UTXO in the contract, which at any time can be claimed by the user. And so the off-chain logic for this needs to be searching through all of these orders and sort of matching orders for users, batching transactions. And that's, again, something that's somewhat beneficial because it takes that load off of the chain, but it's definitely not any easier to sort of grasp with logically. To give a brief overview of the lecture I just gave, smart contracts live on a blockchain, and they're used for a variety of peer-to-peer systems, which I'll be talking about more here in just a moment, which can be arbitrarily complex. They are very prone to developer error, which I think if any of you have heard about recent issues, I mean, there's been hundreds of millions of dollars lost in just the past couple of days. So it's definitely no joke, and people need to be really careful when writing these things. But they can be used to create systems that are really beneficial, whether it be sort of these concepts of multi-signature wallets, decentralized exchanges, decentralized autonomous organizations, and other things. If anybody has any questions about what I've covered so far, I would like to take the time to answer those questions now, and then I'll get into the next part of this. Yeah, so for anyone who didn't hear the question, it was if I could explain a little bit more about the difference between native scripts and the more expressive contracts that we have in Cardano. And the more expressive smart contracts are actually called Plutus scripts. So in a native script, you define a native script. I hope everyone's familiar with like JSON file format. It's just a way to describe arbitrary data, but in the context of a native script, that data needs to follow a certain format. And you can define signers. You can define a number of them that are required to sign a transaction that's going to spend from that native script. You can also define a certain period of time or like moment in time where the transactions either need to be spent after that period of time, so you could use it for something like vesting, or you can say that it can't spend after a certain period of time, which means that the money locked in that address would be locked forever after that moment. So there's not a whole lot you can do with native scripts. That's the only functionality that they offer. Whereas with Plutus scripts, you have, again, like I said before, this sort of idea of data that is actually attached to each UTXO, and the validators can be written using Haskell is the primary language that's being used. There's also a couple of other languages that people have written to be able to compile to Cardano smart contracts using the Plutus core, which is sort of like I said, contracts are made up of just small instructions on chain. And and there's like a compiler that takes the language that the developer actually writes and converts the language that the developer writes into these instructions. And so those instructions on Cardano are called Plutus core, but anything can be represented by those instructions, and it's much more expressive than just the native script functionality, and you can create peer-to-peer exchanges, lending protocols, synthetics, and other sort of primitives by using Plutus, and you can't do any of that with native scripts. Like I said before, it's also really nice because if you have a native script, it's very easy to audit, and you could just show anybody kind of the configuration that was used and show them what is contained in that native script. There's no sort of needing to explain any programming for people to be able to see who's able to sign and all of that, right? Yeah. Are there any other questions?
Okay, so here's a question from the audience. Like, how is using blockchain better than just using a database?
Yeah, the primary benefit of using blockchain is that it's, by being decentralized, you're creating a system that is not able to just be stopped by a centralized entity. You're actually able to participate, like I said before, in the validation of the ledger. If you're a user of this distributed ledger, that's something that I think is quite nice, being able to be participating in the actual validation of that. It's basically the benefit is self-ownership, but I think that there are a lot of blockchains out there that are closer to being databases than blockchains because they have not prioritized decentralization. So I think it's a really good point in the context of not prioritizing decentralization. I think using a database might be better.
And here's another question from the audience. Like, you want to ask that which books would you recommend to dive into this topic?
Yeah, that's a really good question. I kind of approached it just from like a computer science standpoint. So I guess I could list computer science books or books that I've used to learn that type of content. But when it comes to actually learning about blockchain and the ethos behind it, a lot of my learning has been community-based, and I really only dove in heavily last year. So I would say the easiest way to really learn more, if you're looking not just like from a programming standpoint, but from a sort of learning about blockchain and such from a user standpoint, dive into some communities. Discord is a really great tool, and so is Telegram. A lot of these communities have those sort of collaborative tools to be talking to one another. If you check out on Twitter, ADAO community, ADAO community, our Discord link is in that Twitter bio, and we have a lot of people that would be happy to have conversations and always chat about this type of stuff. Lots of academics and builders. But no, I don't think I have any specific book recommendations for blockchain.